Today I'm going to take you through how to calculate the slope of a line from a graph with data. So I've already got the data up here plotted. I measured how many balloons I could inflate over the course of about an hour and a half, 90 minutes. And I took readings every so often and recorded not only when I took them, how many minutes had passed, but also then how many balloons I'd blown up, and got these data. And so once you plot it, the next thing to do is notice this is basically in a line going up. So I'm going to put a best fit line on it with a ruler, of course, because it's a line and I want it to be straight. My data should go sort of as an average value here, so that there will be some points above and some points below, and I'm not going to just connect the dots. I wouldn't be able to do much with that. So I'm going to lay my ruler down. You can see that I'll have some above and some below my line. Draw my straight line here. Even extend it a little bit. Like so. Okay, and now once I do that, I'm not going to use those blue data points anymore. In fact, I could just as easily go by and erase them because they aren't of use to me anymore. Once I draw this line, that's what I want to use. To find the slope, I'm going to look for a couple points on my line where the line itself that I just drew goes through across an intersection of lines on my graph paper, and I'm going to circle them. So looking down here, I've got a great one right there. And I've got another one right, that's a very good one, yeah. I'll use that. And whether my line goes up and down, all of these steps are exactly the same. The point I circled that's on the left of the graph is my number 1 point. The point on the right of the graph is my number 2 point. Just like any point on any graph, this will have coordinates x and y. So since this is my point 1, I'm going to mark it as x1 and y1 and x2 and y2 up here. These refer to the coordinates of that point. To find them, my x of point 1 I take and I drop straight down to the axis down here and I read off the label. So that's halfway in between 20 and 30, so that must be 25, and always put the units. This was measured in minutes. Don't just put 25, always put the units. The y coordinate, I follow over here. It is midway between my 40 and my 50 balloons, so that is 45, and I'll put a lowercase b to represent balloons. I'll do the same thing at point 2. Straight down at the bottom, that is, let me make sure I got that right, halfway in, so a quarter of the way in between 70 and 80. So it'd be 70, 72.5, 75, 77.5. This is at the 72.5 minute mark. And then I follow it across y-axis. I had 120 balloons, 120B. Okay, I'm going to record these just off to the side so I know the 2 points, because then I'm going to do a little bit of math behind this. Actually, I can do it on here. So slope is always found the same way. You probably remember that it's rise over run. In math class, you can often just count the number of squares, because every square has the same size, 1. Here you can't. If we're counting across the bottom, the run, each square has a width of 2.5 minutes. If we're going up on the y-axis, each square has the height of 5 balloons. So we have to be using these numbers to find it, rather than just counting squares. The formula for slope is always y2 minus y1. That gives us the change in the y value over x2 minus x1. Now, I've already written what these values are. So all I have to do is put the values in, and then we'll evaluate. My y2, the y value of 0.2 is 120 balloons, minus y1, the y value here, 45 balloons, I'm going to divide that by x2, 72.5 minutes, minus x1, 25 minutes. You can always use your calculator in my class to do this. Slope then is going to be equal to 120 minus 45 is 75 balloons. 72.5 minus 25 minutes is 47.5 minutes. And then to find my final answer, I need to divide those. So hang on one sec while I grab my calculator. I'm going to divide the number first. So 75 divided by 47.5 gives me a number value of 1.57894. Just round it to a couple decimal places. We aren't dealing with the rules of where you should round it. So 1.58 or 1.6 is fine. Oops. So either 1.58 or 1.6. And then I don't want to forget these units. The units that I just wrote, the balloons over minutes, just get rewritten. Balloons over minutes. It's 1.58 balloons per minute is how we read it. And that's my average rate for inflating over this time. Okay? Every slope that you do should look something like this with a number and the units. Now if it's going downwards, the only thing that changes in this is that the y1, it's still on the right-hand side, but it will be smaller than the y2 will be smaller than the y1. So you'll end up with a negative number on top. That'll give you a negative slope. Everything else is the same though.